Hello and welcome to Chapter 9. We will be continuing with geometry, this time looking at three-dimensional shapes. We will not do an exhaustive discussion of every shape, which is why you have a formula sheet. You can use that for the shapes we do cover as well as the ones we do not look at in as much detail. We will begin with right prisms. These are all examples of right prisms. What makes them a right prism is they form a 90-degree angle with their base and their side. So we see here, right, coming from the base, it goes straight up perpendicular to the base. The base is always the shape that is not a rectangle. All of the sides of prisms are rectangles, whereas the bases are not in most cases. Here our base is our pentagon shape for top and bottom. Right? When that prism is on its side, the base is still that pentagon shape. For a triangular prism, your bases are your triangle shape, and then your sides, your lateral sides, are all in the shape of rectangles. If we have a rectangular prism, it doesn't really matter what we choose to be our base. Right? Our base could be this long rectangle here up top and its opposite side. Right? Those could be the bases of this rectangular prism. If it's up on its side like this, right, then we can consider this square shape to be the bases. As long as the sides are rectangular and we have a 90-degree angle going from our base up for our sides, they are right prisms. Our formulas for right prisms: we have our lateral surface area, L, is equal to P times H, where P is the perimeter of the base. So if we're looking at the right triangular prism, the perimeter of the base is the distance around the base, multiplied by the height being the distance from one base to the other. So to find the lateral surface area, we multiply perimeter times height. The total surface area of a prism, you add the lateral surface area, which we get from our previous formula, and then add to it 2 times the area of your base. So A here stands for the area of the base, and since there are 2 bases, that's why we multiply it by 2. Finally, our volume is going to be the area of the base multiplied by the height. Let's go ahead and practice that with some numbers. So here, to calculate the lateral surface area of this right triangular prism, I need to first find the perimeter. The perimeter is the distance around the base, so 6 plus 10 plus 8. If I add that all up, I get 24, right, 24 inches. Then to find my lateral surface area, I take my 24, multiply it by 15, and I get 360 inches squared. So our units are inches squared because, as always, our units of area are always going to be squared. We're looking at a two-dimensional shape there. For surface area, again, it's an area, so our units again will be squared. We are going to add our lateral surface area plus 2 times the area of our base. So to find the area of our base, we come over here and take a look at our base. The base down here is the same as the base up top. We need to find the height and base of the triangle here. Again, not the same height as the prism or the base of the prism, the height and base of the triangle itself. If you recall, if we're dealing with a right triangle, our height and base, our base is one of the legs and our height is the other leg. So we can call 8 here our base and 6 inches our height of that triangle. So the area of the base then is 1/2 the little b, 8, times the height of 6. So we have 1/2 times 8 times 6, we get 24. Again, we are in inches squared. Surface area is equal to our lateral surface area, 360 inches squared, plus 2 times our area of the base, 24. So we have 2 times 24 giving us 48, plus our 360, we get 408 inches squared as the surface area of this right triangular prism. That's the area of the bases and all of the sides. Finally, the volume of this. Volume is our area of the base, which we already found to be 24, times the height of 15. Multiply that together and we get 360, and our units now are inches cubed. And when we're dealing with volume, we're dealing with a three-dimensional object, and our units are cubed. So even though it has the same number as our lateral surface area that we found earlier, it is a completely different measurement because it's talking about a cubic inch versus a squared inch, a three-dimensional object versus a two-dimensional object. So those are our right prisms. Next we'll look at pyramids and frustums of pyramids. Pyramids have a base, right, just as the prisms do, except their other side has no base. It all comes to a point, which means for any shape of a pyramid, regardless of the shape of its base, its lateral sides are always triangles. So we see here for a square pyramid where the base is a square, each side is a triangle. Same for a triangular pyramid. Here we have pyramids with a pentagon base or a hexagon base, all of which have lateral sides in the shape of triangles. Our formulas will be relatively similar to our right prisms. Here our lateral surface area is 1/2 the perimeter times the slant height. S here is the slant height. Slant height is the distance from the top point down along one of the lateral sides to the base. So that is our slant height. So that distance times the perimeter of the base times 1/2 gives us our lateral surface area. Our total surface area, again, is the lateral surface area plus the area of the base, this time just one base since there is only one base for pyramids. Then our volume is 1/3 times the area of the base times the height of the pyramid. The height of a pyramid goes from that top point down to the base and is perfectly perpendicular with the base. For frustums of pyramids, our formulas are a little more complicated, but again, the pieces are the same. Right? The distance from the top down to the base, that perpendicular height, right? That's the height of our frustum of a pyramid. And then that distance from the top down to the base along one of the sides is our slant height. Right? Same here, right? Our height, again, perpendicular to each base. Slant height going along the side of the frustum. Our formulas here, we have P1 and P2. P1 refers to the perimeter around the top of the frustum. P2 refers to the perimeter around the bottom of the frustum. A1 then is the area of that top base, and A2 is the area of the bottom base. Those formulas will depend on the shape of the frustum. For example, for this square frustum of a pyramid, our area is just length times width, or side times side if it is a perfect square. Our perimeter for any of them will always just be adding up the four sides. We could also have a triangular frustum of a pyramid, again a base with a triangle. Right? Our area then would be half base times height, or if we had, say, a hexagon as our base, right? We know the formula for the area of a hexagon, we can use that to find the base. Let's go ahead and practice this with the frustum of a pyramid. And since the formulas for the regular right pyramids are pretty similar to the right prisms, we'll go ahead and leave those for homework and possibly in class. So for this frustum of a pyramid, if we want to find the lateral surface area, again that's the four sides of this frustum, we first need to find the perimeters, the perimeter of the top base and the perimeter of the bottom base. So P1 is the perimeter of the top base, and that is the distance all the way around here. We see that this is a square, so every side here has a distance of 9 inches. The perimeter then is 4 times that 9 inches, or 36 inches. Our P2 is the perimeter around the bottom. Okay, again, it is a square, both with sides 15, so perimeter is 4 times 15, and we get 60 inches. Our slant height, again, slant height is this height here along one of the sides. It is 5 inches. So therefore, our lateral surface area is equal to 1/2 times P1 of 36 plus P2 of 60 multiplied by our slant height of 5. We take 36 plus 60, we get 96. Divide that by 2, we get 48 times 5, which is 240. And this is a lateral surface area, which means it is an area and our units are inches squared. We could also easily find the total surface area of this frustum of a pyramid. Again, remember, surface area is just our lateral surface area plus the area of our bases. In this case, we have 2 bases, and they are called A1 and A2. We won't go ahead and solve this at the moment, but this would be our formula for the surface area of the frustum. Most of the time, though, we'll just be looking for the lateral surface area or the volume of a frustum. To find the volume, we do need to find the area of the 2 bases. A1, right, the area of that top is side times side because it is a square. So we have 9 squared, giving us area of 81, and that's inches squared. Our second area, the area of the larger base, is 15 squared, which gives us a bottom area of 225 inches squared. So those are the areas of our bases. To find the volume then, we need the height, which we have here is 4 inches, and our areas, which we just found. So volume is equal to 1/3 times the height of 4 times the area of the bottom base, 81, plus 225, plus the square root of 81 times 225. So we need to plug all of this into our calculator and find that. The square root of 81 times 225 is 135. We add that to 225 and 81, and we get a total of 441. And then we multiply that by 4 and divide it all by 3, and we find that the volume is equal to 588, and our units are cubed, inches cubed. So that is the volume of our frustum of a pyramid. Next, we'll take a look at cylinders. Cylinders are set up rather similarly to right prisms. They have a base at top and bottom, and they have the same shape at top and bottom. The only difference here, again, the cylinder has a base that is a circle. For the sides of a cylinder, if I were to cut down the side of this cylinder, think of it as a can, and I cut down the side of the can, and then I open it up, that shape would form a rectangle. One way we can think of the lateral surface area then is the area of a rectangle. We have the height of the cylinder, right? That's the distance from one base to the other. The height can be thought of as the width of that rectangle, and the circumference of the circle then is then the length of that rectangle. So our formula for the lateral surface area is circumference of our circle times height, or 2 pi r, which is the formula for circumference times height, or pi dh. Our volume then is the area of the base, pi r squared, times the height of the cylinder. Other forms we can find it in, right? 1/4 times pi times the diameter squared times height, where 1/4 times pi is about 0.7854. So this is an approximation of the volume. We'll also take a look at spheres. Spheres are actually quite simple. They only have two measurements. The distance from the center to the edge is the radius, and the distance from one edge to the other going through the center is the diameter. The surface area, that is the outside edge everywhere on the surface of that ball, that is 4 times pi times the radius squared, or just pi times the diameter squared. The volume, we have 4 pi times the radius cubed, all divided by 3, which is the same as pi times the diameter cubed divided by 6. So either method we can use there, depending on whether we know the diameter or the radius. Of course, if we know one, we can always find the other. The radius is always half of the diameter, or the diameter is twice as long as the radius. We'll leave cylinders for practice in the homework, again because they are very similar to right prisms, and all we need to solve them is our radius and height, just to plug that into our formula. So let's go ahead and practice our sphere. So if we have a sphere here with a radius of 4.5 inches, right, that radius lends itself to this first formula here for surface area. So surface area is 4 times pi times 4.5 squared. 4.5 squared is 20.25. We multiply that by 4 pi and we get 254.34. And our units are inches squared. So again, this is an area and our units are always squared. For the volume of the sphere, again we have the radius, so we'll use that first formula there. The volume is 4 times pi times 4.5 cubed all over 3. 4.5 cubed is 91.125. Multiply that by 4 pi and divide it by 3. And we get 381.51, and our units are cubed since we are dealing with a volume. For both of these examples, I used pi equal to 3.14, just using that approximation of pi for both of these formulas to get my answers. That is what we will be using most of the time, that approximation of pi. Next, we'll take a look at cones and frustums of cones. Cone is very similar to a pyramid, except instead of a polygon for a base, it has a circle for a base and then comes up to a point. Again, the outside lateral surface of a cone is smooth all the way around. We have our measurements here, the radius of our base, right? It's a circle, so it has a radius. The height of our cone is from that top point down to the base. Again, perpendicular to the base up to that top point. And then we have a slant height, as same as we did for pyramids. That slant height going from that top point along the edge to the base. Our formulas for a cone, we have the lateral surface area, which is pi times the radius of the base times the slant height. That will give us the lateral surface area, that surface area outside here. Or we can also use the diameter of the base, 1/2 times pi times the diameter times that slant height. And that will give us that outside area there. The volume, take 1/3 pi times the radius squared times the height. And now we're using the height from that top point down to the base. We can also find the volume using the diameter, 1/12 now, times pi d squared times the height. So those are our cones. A frustum of a cone is just a cone with its top cut off, creating this new smaller base. Our measurements are very similar to that of a frustum of a pyramid, except again our bases are circles. We have a small radius, R1, and a larger radius, R2. We have our slant height still, and the height of the frustum of the cone. Our formulas for the lateral surface area are slightly modified from the cone. Our lateral surface area for the frustum is pi times the slant height times the addition of R1 plus R2. So adding those two radii together and multiplying that by pi times the slant height will give us that lateral surface area, this area around the sides. If we wanted the total surface area, again we could just add the area of this top circle and the area of the bottom circle. The formula for our volume, 1/3 times pi times the height, again from one base to the other, and then multiplied by the small radius squared plus the larger radius squared plus the smaller radius times the larger radius. We can also use diameters. Right? The same thing here with diameters, except now we have a fraction of 1/12 to accommodate for the larger size of the diameters. We've done a lot of plugging into these types of formulas already, so let's go ahead and take a look at a more interesting case and find the lateral surface area and volume of that case. Alright, let's play around with this shape. We have here a cylinder attached to a frustum of a cone. Up top we have our formulas for the lateral surface area and volume of a cylinder, as well as the lateral surface area and volume of a frustum of a cone. What we're going to do is find the lateral surface area and total surface area of this shape, and then we'll go ahead and find the volume of that shape. So we need to identify our parts here. For this cylinder, we have a radius and a height. Right? Our radius 7.3 inches and our height of 15.7 inches. For the frustum, we need a radius 1 and a radius 2. Remember, radius 1 is our small radius, and radius 2 is our larger radius. For the frustum here, that smaller radius is 2.1 inches, and the larger radius is the same radius as that of the cylinder, 7.3 inches. We also have here the slant height of 6.3 inches, and the total height of the frustum at 3.6 inches. So we'll need that slant height for the lateral surface area and the height for the volume of that frustum. Let's go ahead then and first find the lateral surface area of this image. Right, the lateral surface area would be the lateral surface area of the cylinder plus the lateral surface area of the frustum. So lateral surface area of the cylinder, we know that lateral surface area is 2 times pi times the radius of 7.3 times our height of 15.7. If I use 3.14 for pi, I get 719.7508. And this is surface area, so I have inches squared. So this is the lateral surface area of the cylinder. The lateral surface area for the frustum then, we have L is equal to pi times the slant height of 6.3 times the small radius 2.1 times the larger radius 7.3. And that is our lateral surface area. Again, using 3.14 for pi, we get 303.25806. And again, our units are inches squared. So to find the total lateral surface area, we have L, we'll call that LT for total lateral surface area. We just have to add these together, 719.7508 plus our 303.25806, and our total lateral surface area is 1023.00886, and that is inches squared. So that is our lateral surface area. In order to find the total surface area, we need to take our total lateral surface area and add to it the area of this base here, this large top base, and this small bottom base. So we'll go ahead and find those next. So the area of a circle is pi times radius squared, so the area of the cylinder's base is pi times 7.3 squared. Using again 3.14 for pi, we get 167.3306. And again, this is inches squared. The area of that bottom base then, the area of the frustum, is also pi times radius squared, this time at 2.1 squared. Again, using 3.14 for pi, we get 13.8474 and inches squared for our units. Our total surface area then of this object is adding all of these together. So adding 1023.00886 plus 167.3306 and 13.8479, we get 1204.18686. And our units are inches squared. We can then round this, round that to the hundredths place. We'll call our surface area 1204.19 inches squared. That is the surface area of that shape. Next, we'll go ahead and find the volume of that shape. So to find the volume of that shape, we need to find the volume of the cylinder and the volume of the frustum. To find the volume of the cylinder, volume is pi times radius squared, 7.3 squared, times the height, 15.7. Again, using 3.14 for pi, we get 2,627.09042. And our units now are inches cubed, since we're now dealing with volume. The volume of the frustum then, that volume is 1/3 times pi times the height, which is 3.6. We multiply that then by the small radius squared plus the larger radius squared plus the two multiplied together. So we have 2.1 squared plus 7.3 squared plus 2.1 times 7.3. Multiplying that all together, we find the volume is 275.17704, and our volume is still in inches cubed for our units. To find the total volume of this shape then, we have to add those two together. So our volume total, we get 2,902.26746 units of inches cubed. We can then also round this then to the nearest hundredths place. Volume total is 2,902.27 inches cubed. Make sure you always wait until the very last answer to round, and only round again if you are asked to round. Otherwise you can leave it as accurate as you found it. So if you noticed, for both the surface area and the volume, I waited until the very last moment to round my answer. Be sure to do the same. And we've now successfully found the lateral surface area, the total surface area, and the volume of this shape, which is the combination of a cylinder and a frustum of a cone. That will do it for Chapter 9. Be sure to take notes on this, review it, and bring your questions and homework to class. I'll see you then.